Nakama. In this video we will talk about expression in C programming. So expressions are gross value or calculation. Okay, let me create a new file. Create a new file, expression.c. Okay, let me include stdio.h with main function, and okay, expression in C, it look like, okay, let me do an example here. It's like 1 2 plus 3 plus 5, for example. Okay, times 10 minus 4 divided by 2. That is an example. Okay, an example of expression. So this, for example, is just a value. Okay, a gross value, so we can consider it like expression, but it's not an operation. So expression use some operators, different operators, basic, and then operators are basic tools for building expression, and C has a rich collection of them. So we have the like rudimentary operators. We have arithmetic operator. Okay, and then we have relational operators and logical operators. Okay, so like arithmetic operators, we have plus, minus, times, divided, and reminder. This person is a reminder, or modulus operators. And relational operators, we have equal, if a value is equal at this value, or greater than, or smaller than, or greater than or equal. Okay, greater or equal than, tell the such value. Okay, it's relational for it's for compare to value. And then logical operators is for join two relational, it's for join two condition. Okay, C doesn't stop here. We have many operators. I can do a quick research, table of operators in C programming. Operators and operands. Okay, let's take the first link. Okay, that is, you have many operators. Plus, minus, shift. Okay, bitwise shift. You have many. We will have opportunity to use some of them. Okay, it was just to show you. So in an arithmetic operator, we can divide it in 3 different types. Okay, we have unary, Okay, let's take it there. You have unary operators. Unary operator is plus and minus. Okay, an example of that, you can do int variable, I call it a equal plus 10, for example. Okay, this plus before my value is a unary operator, or I can use minus. Okay, my second variable b minus 5. So that is a comment. We have arithmetic operators, unary. Okay, unary unary operators. So that is for plus and minus unary operator. You can have binary operator. So binary operator is, you can applicate it on two value or more. Okay, so for example, arithmetic operator, you can have okay, you can have int sum, a variable called sum, equal x plus a. Okay, x plus a, the plus inside this operation is used as binary operator, not as unary operator. Okay, you can have addition, you can have the difference. Okay, you can have product or division or modulus. So for modulus, for example, x divided by 3. Okay, modulus just give us the remainder, the remainder of the division. For example, 10 divided by 3 give us 3, and then the remainder is 1. Okay, so see if I print it is a integer, I print remainder to see the content of it. I compile expression.c, I call it just expression, I execute it, expression. Okay, that is one. Okay, let me put backslash n, recompile and execute. Okay, you can see 1, because 10 divided by 3 gives 3, but the remainder is 1. Okay, so this operator is to take the remainder. Okay, you can print those different value if you want, but I think it's okay for this explanation. So these operators are different precedents. Okay, we have plus the highest. Okay, highest precedence, we have plus and minus as unary. Okay, and then we have multiplication, division, and modulus. Okay, after the unary operator, and then you have binary operators, plus, minus. Okay, and we have relation operators. At the end we have logical operators. Okay, and in logical operator we have and then or. Okay, and the last is not. So the most important thing is just to to get about those first operators. Okay, in the manipulation we will get that for the next operators, but the most important thing is the unary operator is as the highest precedence. After we have times, divided, modulus. After we have plus and minus, but don't forget it's a binary operators. I have not precise there. Binary operators. Okay, so that is all the arithmetic operators, but we have unary operators and binary operators. Okay, let me remove it from them. Okay, in arithmetic operator we have those two types of operators here. So for example, I can create a variable. I know this part precedence example. I can create this example. We have 10 plus 5 times 2. The computer in reality it doesn't know the which operation it has to do before which another. So there is a precedence of multiplication before this, so the computer do this operation. Okay, then addition, let me complete. So the computer do this, it take your instruction and it do 10 and put parentheses like that before to do it, because parentheses say to the computer, okay, do this operation before this operation. So if you want to explicitly tell your computer to do it before, you have to put parentheses at this level. Okay, so to make it more precedence than the multiplication. So we can have another example. Okay, let's print the result. Before that, it looks like simple mathematics. It's not really okay. That's the result. But if I decide to do this before, I can put it like that, and then the result become 30. Okay, 30. So let's like that. Assignment, we can have assignment like assignment is an operator. Okay, this a variable equal a value, okay, or an operation. This is not an instruction, but it's not an instruction but operation, because it give you a result. Okay, the result of this variable, the variable result. Okay, let me show you something. I can do another thing. I can remove it here and put directly in print. Okay, I can do this. Not the declaration. I can just declare the variable here. Okay, I can declare here int result like that, and then I use the assignment operator. I print the assignment operator. Okay, so this variable take this the result of this operation and I print all this operation, okay, is because this is not an instruction like int result. Int result is an instruction, okay, because it is finished by semicolon, but this is not it's not mandatory to finish by semicolon, okay. So you can print this because this is a value, okay, at the end is a value and the value is the value of the result inside this variable. So this, okay, so let me execute. Let's execute. Okay, it's give 20. Okay, 5 times 2 give 10 plus 10 20. That's the result here. So you can print directly a assignment operation like that. Don't be mistakes with assignment, okay. You cannot with declaration, you cannot do int result like that because it's become an instruction, okay. But this is just the assignment. The assignment is a operation and you can print it, you can store it inside a new variable if you want. So if I create another variable, so I call it just var, okay, and then I can do this type of operation because this is just an operation. It's evaluate and then it gives 20. So like it's become 20, okay. So 20, this 20 is assigned in var, okay, my variable var. That is why you can do this type of operation. We call it aggregate operation, okay, aggregate assignment. You do operation and you assign the variable, and this result, the result of this operation inside your variable can be assigned at the another variable, and you can do it again and again, okay. So okay, that's all for this. And the simple assignment, in the simple assignment you can do simple assignment do implicit conversion, implicit type conversion. So for example, we have an int like that, float, and then you can do okay, let me, you can do int var, I call it var result equal okay, equal my float variable. So the result of that, it take the value of float var, okay, float var is my variable here. It take this value 2.5 and it converts it implicitly in type 8, in int integer, because this variable is a type int, so it can just take a integer variable. So that is we call implicit conversion. We will talk about explicit conversion later, so that is why I want to show you. So this operator can do implicit conversion, okay. It's important to get it now. And okay, let me change a comment inside here. That is the implicit conversion, okay. What I want to show you again, several assuming, okay. we have a we have what we call L value. So L value and air value. Okay, well, let's talk just about L value. L value in fact is, for example, I have a variable, I call it number. I have a variable number and I assign 10. Number is an L value. Okay, this is an L value because you cannot, it is not a operation. When you do an assignment like that, okay, the operator at left, okay, L values means left value, okay, the most left value, because you can have an assignment like that. You can have for example, I can use x b equal 10 like that. Okay, it's permit. I've explained here before. So you can do it, and the most left value we call it L value because it cannot be an operation. Everything here could be operation. I can do for example, I can do +1 like that. No, I can do +1 just here. So I can use, for example, b plus 10. Okay, I can do operation with a variable and a value, a gross value. But assignment, the value at the left, okay, it could be an operation. Okay, it could be something like -1 like that. Okay, you cannot assign a value at an operation. Okay, it's just normal. Okay, that's why I call it. It's important to understand this now. And we have that we call compound assignment. So compound assignment, compound assignment compound assignment compound assignment in fact is this. Okay, I've already explained it. Just 10 and maybe a b equal 10, for example. Okay, that is what we call compound assignment. So let me remove this. Just let stay with 10 like that. Okay, that's what you call compound assignment. But it's not it's dangerous to use it every time. It's better to never use it like that. So for example, for this case, for example, it's better to block it in many lines. So you define your b alone. So b equal 10 and then do a equal b. Okay, if you have declared a, can do a equal b and then num equal a, and then yes, num equal a is the last. Okay, it's better to do like this. Okay, instead like this. So but there are some case you have to do like this. There are some case, okay, but it's always better to do like this. The last thing I want to show you is increments and decrements operator. Okay, increment. So increment operator is just look like if I have int value I equal 5, for example. If I do I plus plus, my variable is added by 1. Okay, so 5 plus 1, my value I is it become 6. If I do minus minus, decremented is become 5 again. So I can, okay, let me show you directly with printf. If I print my variable, okay, you see here 6 is the new value of 6. So incrementation is just to add 1, and decrementation, okay, decrementation is just to remove. But you can use plus before the name of the variable, like that. The difference is in this instruction, the new value, okay, the operator before the variable means the variable changed directly at this instruction. So for example, let me show you this well. If I print directly my, okay, that is we call post decremented. Okay, post, because we will see the result at the next instruction. Okay, so let me show you the value didn't change. Okay, we will see 6 always 6. Okay, 6, because the value doesn't change at this line. Okay, you can print an incrementation because it's a operation. Okay, any operation like you have seen here, for example, it is an operation. Assignment is an operation, incrementation is an operation, so you can print it, or you can put inside another variable, in another variable, or do some operation with it, because it's just an operation. Okay, like, so that is why I can print the incrementation operation. Okay, it is a operation. So when I do e plus plus, I put the plus after the name of the variable. Is a post incremented. Okay, in this case is incremented, post incrementation. So that is why you see always see 6. If I print the new value of my I, okay, without incrementation or decrementation, just the value, the actual value of I is 7. Okay, so 6 here is for this line. Okay, I have do e plus plus, and then I have print it. I do e plus plus again here, so it is post incremented. So at this line, at this instruction, the variable doesn't change, it changed after this instruction. So that is why the next instruction print 7. So pre-incrementation now. Okay, let me remove it. If I do pre-incremented, yes, pre-incremented, and then I print the value. So pre-incremented change the value at the same instruction. Okay, the same line directly. Okay, that is why you see 8. Okay, we don't need this next line to see, because the value has anyway has changed. Okay, at the same line, this is for this line, at the same line the incrementation has already worked. Okay, so it's the same thing for the incrementation. The incrementation is just to remove 1. So we can do for example, quick can do post incremented and see how the value change at the next line because it's the post decrementation. Okay, we have 8 and 8 again, 8 two times. It's just at the new line here we have 7. So let me arrange all this incremented by 1. Okay, so let me, I is incremented, and here I is incremented for the next instruction. Okay, and here actual value of I okay, let me just put actual value of I everywhere. I doesn't change. I just, so here pre-incrementation I put I as change directly at this instruction. Yeah, high as incremented directly, high as incremented for the next instruction. Okay, and here actual value of I. Okay, I think for the presentation it's better like that. Actual value of I, so I start with 5 and then I do a simple like incrementation instruction here. So the actual value of I is 6. Okay, no problem. So I is incremented for the next instruction, so I've print I plus plus, okay, the operation plus plus, but the value doesn't change here. That is why I print I is incremented for the next instruction. So I print it's print the same value, the actual value of I. So at the next instruction, then the actual value is 7. So I has incremented directly at this instruction 8. So I have print the pre-incrementation. Okay, here it was a post pre-incrementation directly the variable change at this line. That's why you have 7. So here I has incremented directly at this instruction 8. So okay, that's the line I was talking about. So I as decremented for the next instruction is this line. Okay, I have do a post decrementation. That's why see it's at this line I keep the same value 8 that the last. Okay, it's the same value, and then the actual value, so at the next it's changed because the incrementation at the precedent expression. Okay, with the practice we will get it easily. Okay, it may be difficult to get, but it's easy. It's very easy, just with small practice, and you get it. I think that's all for this video. Just a small warning. Okay, small warning to finish the video. For okay, let me do it like for this type of assignment. Okay, that is what we have already talked about. For example, minus a equal 1, like that. This type of operation, you have to avoid it. Okay, this part is warning. complex version with side effect like okay. It causes a side effect because you have to avoid it because it causes a side effect. So an unpredictable result. Okay, you have to avoid this type. I've explained that. Somewhere here. I've explained that before. Okay, you have to avoid it. And the next warning is do something like I have a variable g and I do I plus. It's possible to do it, but you have to avoid this type of operation because it has two side effects. Okay, it has two side effects. Okay, you don't have to go deeply with the explanation, but just avoid to have this type of operation. The variable itself and the incrementation inside the same instruction, the same statement. It's sufficient for this video. There is no exercise for this video. There is no exercise. Anyway, if I have an exercise, I just add it. But for the moment, there is no exercise. So it was all for this video, and take care of you, Nakama.
Je fais le portrait comme au Beaux-Arts, loyal, poli, droit et sincère. Je respecte le code du Bushido. Mais si on met les armes à terre, c'est pour te faire une prise d'aïkido. Et la concurrence au cimetière, ne pensez pas mourir aussitôt. Mon katana taille leurs artères et broie leurs organes génitaux. Quand j'étais gauche, j'en ai pris des coups, j'en ai dans le ventre comme un seppuku.